Higher Mathematics, Notes and Examples. This is lesson 3 of Functions and Graphs, and we're looking today at composition of functions. This is an important but quite often difficult idea for pupils in higher mathematics to initially understand, but with practice you will be able to master the concept quite easily. So we think about, first of all, a function, let's say f of x, which is 2x, and that maps elements from one set A to a set B. Another function, g of x, is mapping elements from set B onto another set C, and that function is x plus 7. Really what's going on here is we've got one function which is to double a number, and we've got another function which is to take a number and add on 7. One going from set A to B, the other from B to C. Is there a way to combine these two functions into one single function? Can we double a number and then add on 7? Of course, we know that we can. That function would be a new function we could call h of x, which would be to multiply by 2 and then add 7. So h of x here is composed of these two separate functions, doubling a number and then adding 7. And actually, many functions that you may have seen before can be thought of as composed of 1 or 2 or even 3 different parts. So for example, the function x squared plus 7 or x squared plus 9 is really composed of two things, squaring a number and then adding a constant. If we think about this in terms of our function diagrams, then we get something like this. So the function would map an element from A, not to B and then C, but directly to C, straight to set C. We call that a composite function, where h of x is really g of f of x. We write that, as you can see, with g on the outside, f of x inside the bracket, and we say that as g of f of x. So we need to really look at some examples to see what this idea means in practice, and we're going to do that now. Okay, so let's look at example 1. Express h of x, which equals x cubed plus 5, as a composition of two separate functions. So really, how can we break up this function into two rules or processes? To do that, we'll call them f of x and g of x. So what's the first function? What's the first thing we do to a number? Well, we can see that f of x is just to cube the number. F of x is the first part, which is x cubed. So that would be our first function. F of x equals x cubed. What do we do second? What is the follow-up function? That would be to add on 5. So g of x is x plus 5. And that would be the answer to this particular question. To be clear, we could say that h of x here is a function of a function. H of x is really what happens if we put f of x into g of x. So we call that g of f of x. So that would be putting x cubed into the g function. So that would be g of x cubed. And we can see that that would be replacing x with x cubed plus 5. Again, this can be quite difficult at first, but with practice, it will become much easier. Let's look at another example. Okay, example 2, we're now going to be presented with two functions, f of x and g of x. And we want to find the composite function h of x, which is g of f of x, and then also k of x, which is the other way around, f of g of x. So let's start with h of x. We want to find g of f of x. Now, I would recommend here that we write equals. We leave our g on the outside, we open our brackets. What are we putting into the g function? F of x, which in this example is 2x minus 5. And then what we want to do is in the g function, wherever you see an x, you replace it with 2x minus 5. So clearly we've got an x squared in the g function. That'll be 2x minus 5 all squared minus 1. I would pause the video and look very carefully at what I've done there to make sure you understand how to follow that example. All I'm doing now is breaking the bracket so that we actually have a better, more simplified answer. It's not always necessary to do this, but it can be useful if it's quite simple. In this case, it was quite simple. So again, pause the video and look through that example more carefully, more slowly. Here I'm going to do k of x, which is f of g of x. So again, I would just write that down, and I would highly recommend that you now write equals. You leave your function on the outside. What is it we're going to put into the f function? It's actually g of x, which is x squared minus 1. And that means we're going to have 2 lots of x squared minus 1 minus 5. And again, I'm just going to break that bracket so that we can write a more simplified answer. 2x squared minus 2 minus 5, or 2x squared minus 7. Now we notice here that h of x and k of x are not the same. And it's really important in this particular topic that we make a note of that. So generally speaking, a little nota bene here, little NB. Generally speaking, or if we say in general, and we're really saying that in general, if we find g of f of x, that's not going to be the same as f of g of x. Generally speaking, these are not going to be the same function. That's important to make a note of. Let's do one last example. Okay, this is the final example in this video lesson. So here are our 2 functions. We're going to do 2 things. Part A, we're going to find f of g of 5. And then part B, we're going to take on something a bit more difficult. We'll look at that in a moment. How do we find f of g of 5? Well, we don't actually need to find the composite function, f of g of x here. We could actually approach this by finding g of 5 first of all. So we know that g of 5 means we're going to put 5 into the g function. That'll be 5 minus 3, or 2. And then all we're going to do is to find f of that answer. So we need f of 2. So we've put 5 through the g function, we got out 2. We're now going to put that into the f function, which will be 1 over 2 plus 1, 1/3. So we don't need f of g of x here because we have a number, 5, that we had to evaluate. So watch out for those kind of questions when you're looking at this particular technique. Now, one of the questions that can be a bit more difficult is when we have to find something like f of x. So we're going to put this function through itself, inside itself. And it's also quite a tricky function. So we're doing f of 1 over x plus 1. Now what that means is, in the f function, wherever we see an x, we need to replace it with 1 over x plus 1. So hopefully you can see, and maybe pausing the video is a good idea, that will now lead to 1 over x plus 1 plus 1. That looks quite complicated. That is an answer for f of x. It would be better if we could use some algebra to try and write that in a much simpler form. So what we're going to do is leave the numerator alone. We know that the denominator can be written as 2 fractions added together. We do that by changing 1 to x plus 1 over x plus 1. It's now got the same denominator as the fraction beside it. We know that's still 1. We can now combine the 2 fractions in the bottom into one single fraction. Look at how the 1 is just left alone, but the denominator becomes, now on the top, we're going to have 1 plus x plus 1. That's just x plus 2. And we've got our x plus 1 on the denominator. Finally, if we're dividing by a fraction, of course, we know that we can change that to timesing, multiplying, and flip the fraction. So it should be x plus 1 over x plus 2 times by the 1 on the top, but of course that would just be the same. That's probably one of the more difficult questions, so don't be too worried if you've not fully understood that. With practice in this particular topic, you'll be able to tackle those kind of questions with a greater level of confidence. Okay, it's now over to you to get some practice with these techniques. If you are studying the TG textbook, then you want to be looking at page 23, exercise H 3.3, questions 1 to question 9. And for those of you using the good old Heinemann textbook, page 26, exercise 2C should give you the practice that you need. As always, please remember that there are other lessons in my video series. This is lesson 3 of 4 on this particular higher maths topic. Do check out the others if you need some extra help. That's all from me. I hope that you take it easy, and I'll see you in the next video.